Um, I'm going to talk about Kubernetes. I'm CTO at Showpad. If you want to know more about Showpad, there's a booth that we have. You can ask questions. Maybe just to start, who knows what Kubernetes is? Raise hands. Who has ever done any work in Kubernetes? Cool. Okay, that's good to know. So we at Showpad, we really love Kubernetes. We work with it. We architect our way around it. And I was wondering, because I was kind of like improvising what to say to you today, this afternoon. How could we describe our love for Kubernetes? And one of the best ways to describe your love for anything is by writing a letter, right? So let's write a letter to Kubernetes to tell it, or she, or he, whatever you prefer, about what we like. So it starts with a big problem. How the hell do you pronounce Kubernetes? A lot of people are wondering about that, depending on what region you're from. It doesn't really matter that much. The original creators have a very strange pronunciation for it, by the way, but let's just stick with Kubernetes. Dear Kubernetes, first of all, you need to understand what stage of a relationship you're in with a product, because a lot of people, when they get this new thing, the new tool, and they're like super in love with it, and it's like, yeah, this is the best thing ever. But as long as you haven't done any real work with it, you don't really know, right? So there's different ways of looking at a relationship. There's really complex models, really crazy things. But at Showpad, we've had pretty decent experience with Kubernetes. So ever since mid-2017, all our services are running. So we have a pretty adopted product. We have a lot of, pretty big size of team. So I think we have relevant experience. So the things I can tell you are actually from the field and not from some kind of tutorial book. So what are we running in Kubernetes? Like I said here, stateless flows. So that's the point in Kubernetes. For most people, you run things that are stateless. What does that mean? Simply, PHP is like de facto the poster child of stateless processing. Basically, it gets a request, does something, and then emits a response. And it's actually very hard to engineer stateful applications in PHP, meaning if you do another request that you would rely on the results of the previous request, you would actually need data storage or something like that. And we do a lot of flows like that. So we have HTTP ingress, anything that comes in as an API call and then gets a response. We usually model that in the Kubernetes pods. I'm going to talk about that, how that looks like. But also background workers, so things that like convert video files, convert files, all of those run in Kubernetes pods. So what is not stateless? That's maybe easier to describe than what stateless is. What is not is database systems, for instance. We typically don't run them in our Kubernetes cluster. That's the kind of stuff we run outside of it. So, here in Kubernetes, we had a rocky start, because that's true. When we started out with this tool, we first needed to completely containerize our entire environment to be able to work with Kubernetes, so that was kind of rough. And then there was all sorts of problems we got into. So if you know a little what Kubernetes is, it's a way of describing your applications as pods, and each pod is like a collection of containers. So if you have a service that gets a request, and then the request gets treated by PHP and emits a response, you basically always have a web server that gets your HTTP request, kind of packages it in something that can be understood by a PHP runtime, and reversely gets the response of PHP and then packages it as an HTTP response, right? So you have an Nginx container and a PHP container. And then you make a pod out of that. And the point is with Kubernetes, that's the only thing you need to do. So suppose you get 1 million requests, Kubernetes will try to scale those pods across your infrastructure. So what's the kind of difficulty you have there? Because that looks simple, right? One thing there, if we focus on PHP, because it's easy to explain with PHP, is that PHP is sometimes a little cold. It's like an old car, like a Lada or something, where you need to kick it before it actually can get full speed. That has everything to do with op cache or your own application cache. So just scaling these pods won't work because your users will keep hitting these cold PHP things. So Kubernetes has a thing for that. It's called readiness probes. You can define them, and then you can define when your service is actually ready to receive traffic. That's very handy to do in these situations. Another thing that comes up in production when you try this is, in the ideal world, you would do this, meaning every request would scale a new pod, the pod would treat the requests, and then the pod would disappear. That's like the perfect, for a lot of Kubernetes engineers, that's like perfection. But it doesn't work that way. In real life, that will be very hard to accomplish. You will have a lot of delays, you will have a lot of traffic on your Kubernetes master doing that, because every request would actually cause an action. So what you typically do is, in the case of PHP, is you define something that models multiple PHP workers, and you define a pod around that, right? So you have an Nginx server, and then you have multiple PHP workers, and that's your pod, and that's the thing you scale if needed, meaning that thing can handle 200 concurrent requests. Suppose you suddenly have 400 concurrent requests, it will add another pod so you can handle the traffic. But there's lots of stuff there that can go wrong, because the contract between Nginx and PHP then is no longer atomic, meaning if your PHP dies, or you just downscale PHP workers, it needs to wait. There's a period in time where there's like an incertitude. And that's also something you need to do with Kubernetes, is try to indicate to the system how healthy your pod still is. And that's, again, an instrument that allows for this liveliness probe. You can easily define that, and it's basically binary. You can define, like, hey, my pod is healthy or not. And then, of course, the point is that with Kubernetes, if you've done a couple of these things right, you start scaling, right? So you get requests, and Kubernetes automatically starts scaling pods, like an elastic, whatever, rubber band, whatever you think it is. And you need to test that. That's an important phase where you need to figure out what your parameterization is. Either you can like have, is there like a clear point? Either you can have like tons of PHP processes per pod, or you can have tons of pods. So you need to test that. And how we did that was with Locust, very cool tool, remember it. We also took the effort of running Locust on a different cloud provider than our own service, which is on AWS. Locust was running on Google Cloud. That's just to avoid any interference. If you just run it against your own cloud supplier, you might get a wrong image of how it works. So you end up with load tests. That's what Locust is for. And then you figure out, like, this is a good configuration. We can handle 1 million requests per minute or whatever with this setup. You can do that with all. So that I just gave an example with PHP. You can do Kotlin as well. I'm not sure. Does anybody know Kotlin here? We use it for the backends too, Kotlin. It's a very good backend language. And there's lots of cool stuff you can do. You can think about, if you want to do advanced cases, if you're Kotlin. So Kotlin is JVM based. You know JVM is kind of stateful. You can choose how to use it. But in the end, a Kotlin server would actually be able to, if you have multiple requests, it would understand that it would keep memory between those requests. You could actually share that memory between the pods. That's something we don't do actively in Showpad, but we're thinking about it. Anyway, I think the clicker is, sorry. There's lots of ways of doing that. It's just an advanced case. All right. And there's other, like I told you about background workers, right? So you can also put these in Kubernetes. These are like, with us, we usually use Golang, which should be familiar for the people here. And for instance, there's a video conversion tool there that uses FMPEG. And then we have Golang workers. And then some things can, because these are like long-running processes, like they take a lot of memory. And there's a couple of things I wanted to tell you about that we've faced. When we started out shipping stuff with Kubernetes was at version 0.9. Now it's at version 1.12. And so what we saw is that a lot of times we needed to understand, like, what's the roadmap of Kubernetes, what is possible, can we do GPU-based support or not, is anything holding us back? And often it felt like, hey, you felt like a dog catching its own tail, because every solution we made Suddenly Kubernetes came out with a new version, and they made something else to tackle it, and it was very hard. So that's also something that was quite rocky. So dear Kubernetes, we had a rocky start. Remember when I blamed Flannel for everything? Flannel is kind of like the networking layer in Kubernetes. Nobody understood really how it worked. Everybody started blaming it. In the end, nothing was ever wrong with Flannel. It was just people not understanding the product, understanding the deficiencies, the things that didn't work, and the things that were coming in the roadmap, etc. So rocky start. But yeah, so when you're writing a love letter, you can do that. Small negative touch, but you immediately have to push into the positive news. So let's go romantic. Ever since I first laid eyes on you, yeah, what did we really learn when we started using Kubernetes? And there's a very important thing you learn when you do that. It's that infrastructure is just temporary. It's not meant to be the classic way where you have servers and you manage them, and then you have stuff you put on them. It's the opposite. It's the opposite, basically. You have stuff, and you need it to run it. So you need infrastructure temporarily to run it. So that's basically what we're doing with Kubernetes. We have machines that we define, like, hey, we need 2 EC2s, and we run Kubernetes clusters on top of them, or Kubernetes pods on top of them. And then we suddenly auto-scale a new EC2. Because that's the funny thing about Kubernetes, it kind of interacts with your cloud supplier to auto-provision new stuff. You can even have spot instances. Does anybody know what spot instances are? It's like a very cool model where your price of your machine is determined by the market. So a lot of people are using spot instances, and if like there's a peak, it's like when you have Uber, basically. If you have a surge, if there's a party or whatever in the city, you use Uber, it's going to be a little more expensive just to be able to have the demand curve correct there. Same with Amazon, they have the same thing. You don't know what you're going to pay, basically, it depends on the demand. So ever since I first laid eyes on you, you taught me how everything around us is only fleeting. That's basically what Kubernetes taught us. It's just, everything is just a little temporary. All the infrastructure doesn't really matter. And you could, a lot of ways, a lot of things that people say about that have to do with pets and cattle. Anybody ever heard those words? Pets versus cattle, it's a pattern where you used to treat your infrastructure as pets, meaning you took a lot of care for them. Now you treat them more as cattle. It's just cows that are a little more dispensable. Like pets need vets, right? So they need to have a lot of care. If you have a cow, stuff can go wrong, but it's not really that important. I mean, it's not that bad. Sorry for vegetarians. Anyway, yeah, sometimes these things. An important thing there is immutable infrastructure. So the arrow is time. You have version 1.0. You want to deploy a version 1.01. In the old classic way, you would actually change version 1.0, but in a new way, because it's cattle. That's why it has little horns. You just add 1.01 and then you kill 1.0. That's immutable infrastructure. That's very important. That's the way a lot of modern companies treat infrastructure. And then it gets a little harder to monitor stuff, because when you just update something, it's very easy. You see the curve go down or up. You need to take care of that. So you need to implement that in your tool stack. If you're using these kind of tools, you need to definitely think about monitoring, but the good thing is that most monitoring solutions have built-in support for a lot of this. So cats, so not cats, there's no cats involved, it's pets and cattle, but there's also chickens. Chickens are what is known in the world as containers. So anybody ever works with containers daily, like Docker? Does anybody use that here? Okay, people nodding. So chickens are considered, so containers are considered chickens. I don't think chickens are containers, but the other way around is kind of like a good analogy. And chickens, again, they are even shorter lived than infrastructure. They live maybe for a second or something, and you could just, a lot of people feel even less bad about chickens dying than about cattle dying. So it's a pretty good analogy. And then there's another thing that's starting to come up. It's called functions. So who has ever done like serverless programming with lambdas, or how to, like on Google Cloud platform? And you can consider these as even more temporary, even more fleeting objects. These are just functions. You call them once, and they actually have a limited lifespan by design. They can only last for X seconds or X minutes. They can only take up so much memory. It's by design that they're constrained. And you can do that on your cloud provider. You can also do it on top of Kubernetes. It's a very interesting new way of modeling services. One of the things there that's pretty popular is by Platform 9, I think it's called Fission. And there you can define stuff you used to do on your cloud provider, you can define it on a Kubernetes, and you have complete serverless model done inside Kubernetes. So I have an example of that. So this is a very simple example. With fission, you have fission triggers. Never Google that, because a fission trigger is actually a thing for a nuclear bomb. And if you Google it, I don't know what happens, but it's probably not a great query to do. Anyway, but you have these triggers. For instance, there's a Slack trigger in the whatever package manager there is. Somebody made a Slack trigger. You can then download it and add it to your system, or you can design your own triggers. So it's very easy to add a trigger to Slack and then have a function. But more to our point, to Showpad, what we, for instance, have is a functionality where you have data science. This is data science, and it kind of calculates stuff. And then you need to send out an email every week to people to tell them, like, hey, this is a digest of what's happened in Showpad. And there's algorithms involved, data queries involved, to give like a nice email that guides them to the newest stuff, the most trending, the hot topics. So when we first thought about it, let's do that with Lambda. That's just an example, That's a recent example. And each Lambda function, so that's kind of like the function there that I talked about, would build and send an email. And now what we notice is that a lot of these emails are the same. Like if you have 1,000 users in an organization, a lot of them will get the same emails. So it's kind of pointless to have each of these Lambdas build the emails because they look the same. So this gives a way to a kind of reflection where you can see that if you combine Lambdas with Kubernetes, you kind of get the best of both worlds. So here, for instance, you define pods that actually build and send an email. You only define 2 of them, and you have your Lambdas just HTTP call them. That's kind of like a mixture. It's kind of like the thing you find out when you actually use these things in production, or when you think about using it in production. It's kind of the middle way between chickens, pets, cattle, and the insects I talked about. So, yeah, lots of examples. Sorry, the clicker is kind of weird. But let's talk about the love letter, right? You want to talk about insects. That's not a very good thing to put into love letters. I wouldn't put that in. I had a hard time to give a spin on that. So let's talk about butterflies instead of insects. The same thing. So we add another line to our love letter, very important one, because we do like Kubernetes as it taught us how to architect with that model, right? So yeah, I still feel the flutter of butterflies when it meets. It's a good thing to say, and it's true. With Kubernetes, it still feels fresh every day. So we added another line to our little letter that is becoming very cheesy, obviously. So let's add more cheesy lines. Let's just go all the way. And then money, because everybody has a boss. I have a boss too. Everybody has, I think. And there's business involved. So how much does your infrastructure cost is actually a pretty big factor in any organization. A lot of people think cloud made things cheaper. That's not the case. Definitely not the case, because there's a lot more velocity. A lot of people just start pushing demos into production. You generate a lot of revenue for these cloud providers, and you get a big invoice sometimes every month. And a lot of startups nowadays, they need a lot of money from the get-go to fund their infrastructure. But that's something where Kubernetes helps a ton. Because if you look at, for instance, the traffic of Showpad, which is a business-critical application, people generally don't work in the weekends. And they generally use Showpad a lot less in the weekends. This is an actual graph of our request rate. And so you see the weekends, obviously, and you can see day and night, even though we have a lot of EMEA, a lot of USA consumers. In the Asian region, there's still a lot of market to explore. But even there, there's an area, if you look at the time zones, there's an area in the middle of the ocean where Fiji lies, there's going to be calmer periods across the 24 hours, either way. So a good infrastructure and a good economy model kind of takes that into account. And that's kind of what Kubernetes allows you to do as well, because when this traffic is small, it will automatically downscale your infrastructure to the needs and automatically climb it up again when it gets busier. And there's lots of ways of doing that. It's a very interesting way of looking at it is, do you either, so if these are cores of your CPU, do you either let containers or pods take a number of cores, or do you kind of distribute them? Interesting models you can do, and actually Kubernetes again allows you to play around with that and figure out what's the best for your model. Because in the end, the only thing you pay for in a cloud provider is either storage, network, or CPU time. That's the only thing you basically pay for. And if you look at one important metric that a lot of people tend to forget is CPU idle time. That's the time that the CPU is not doing anything, or not doing anything that is that you wanted to do. And you should always try to minimize CPU idle time, meaning you keep it busy, because CPU idle time is basically burning money, as the image very explicitly tells you. So let's talk about, let's put that in the letter somehow. I treasure each second of our time together as the rarest of jewels. Whatever, doesn't matter. It's as long as the love is mutual, it doesn't really matter what you put in these letters. But then security. Every bigger organization, as it gets more serious about its activity, starts getting more serious about compliance, security. These are two different topics, but still there's a lot of stuff to do about that. And a lot of it has to do as well with what developers can do in your organization. So if you have an organization that allows you to have 1,000 developers working on a platform, you need to have some kind of rules in place so you can be sure that a team has only access to the things they need. And again, Kubernetes allows you to do that, and Docker as well. It allows you to use RBAC, role-based access management. It allows you to define exactly what users have access to what resources. So some users can actually access the network between two pods, or some users can change configuration on a very intricate level. And it's kind of cool because it's a lot more explicit than what you used to have when anybody who works in Windows environments, where you have these LDAP rules and you have to map them to your business, whatever, it gets super complex. With Kubernetes, it stays very explicit and kind of programmers get it, right? So it's also a very good thing. And a lot of things are important there, very easy things. So if you use Kubernetes, always use bastions. Does anybody know what bastions are? It's basically, instead of just being able to log into your machine with SSH, you always have there's only one point where you can log in with SSH, and then that point has access to other machines. And then there's a couple of tools that Kubernetes has to really enforce security policies. Sounds boring, but it's actually pretty nice to do. So yeah, sorry, put that in a letter. It looks like nobody could ever get between us. So, and then looking at the future, how will we use Kubernetes in the future? There's a lot of stuff coming, and not only for Kubernetes in general, for this kind of new model with, like I told you, cattle, chickens, insects, a lot of stuff that's happening right now. Helm, for instance, is a very cool package manager for Kubernetes that allows you to get a full application with all the pods defined just by typing helm get. And you can also design your own applications that way. And if you do that, if you design your own applications with Helm, you can kind of start combining Helm packages, and you can also play very nicely with fishing, the thing I talked to you about serverless. So Helm, pretty cool technology. Envoy as well, that's service mesh. Does anybody know what a service mesh is? Yeah, Albert doesn't count. So that's also something we're looking into, in having something that always sits between traffic and listens to it and acts according to, again, programmatic rules. Actually, you'll notice, I don't know if you know this, but you should definitely check it out. It's called the Cloud Native Computing Foundation. It has a number of projects that are either incubated or whatever the word is when something is incubated. And there's only two things there, that's Kubernetes and Prometheus. They came out of this project. If anybody remembers Apache, but you're all pretty young, but Apache was kind of like the same thing, where you have like this open source initiative that had projects incubating. The same thing happens with Cloud Native Computing Foundation, only the projects are a lot sexier and are a lot just better developed. And there's a lot of other stuff that's now happening there. Like this one I didn't even know until I made a presentation. It's a way to update native applications. So if you have like a car software or something and you want to update it across a fleet of cars and you want to do it securely, it's a pretty complex challenge. And this allows you to do that easily. And there's a couple of other things here that are very interesting to check out. Even just by looking at what they do, you will learn a little more about what they are. Like for instance, gRPC. A lot of you have probably already worked with JSON between two servers. That's like text. JSON is just text. You have basically bytes, and they look like little curly brackets and then at the end there's a 0 byte to end. But with gRPC, it's more of a binary protocol between services. And with 1 byte, you can basically already send out a lot of information. Suppose, for instance, you have a default field value in a schema. With JSON, you would actually have to send that value, right? With gRPC, you could just not send anything, and it would understand at both ends that the defaults are being used. And there's lots of stuff like that. With gRPC, you can also stream data, by the way, which is a little harder to do with JSON. So definitely check it out. Cloud Native Compute. Who already knew this project? Pretty cool website with lots of information. And if you think about, so what I talked about cattle and pets, and insects and chickens, there's a pretty cool evolution happening if you're with it. So if you look at all the new stuff, so there's a couple of things here I didn't mention yet, but all of the new stuff, so to speak, is cheap. Like I told you, with the economy and the burning money, it's a lot cheaper. If you invest the time and money and you R&D properly and you deploy your services that way, it's the cheapest way to do it. If you use like all of Amazon's or Google's services to do things, it will also be cheap, but it will be more expensive, obviously, because they have their own business model behind this. If you use classic IaaS, meaning you just take a virtual machine on Amazon or on Google and put your own stuff there and manage it, it will always be the most expensive model because you will have a lot of CPU idle time, etc. That's funny because its cost is the lowest, but you will have a very high control still, so you can control a lot. Whereas with the middle approach, where you have a PaaS system, where you just use all the candy store in your cloud provider, you don't have a lot of control. If you want to upgrade to a new version of Kubernetes or something and you use it, or a database system, you can't because you're like stuck with whatever Amazon or Google gives you. So how do we put that in the letter? Our future together is as sure as the ocean's tide. So yeah, we're probably going to stick with Kubernetes for a while. Sorry, Kubernetes sometimes skips like through that. But the ocean's tide isn't that sure, right? It's pretty unpredictable. So that's kind of a lie, but it's always good to play safe and stay true to yourself because something might come around, right? We're not sure with Showpad either if Kubernetes is going to stay our favorite container orchestration solution. We've been using it now for 1.5 years, which is not that much. So we're always looking at other things, always keeping the horizon open. But let's not tell that in the letter. Let's just end it nicely. And yeah, that's basically it. I think Kubernetes is a great tool. You should definitely check it out. And really, you can use it locally, like on my Mac or Windows. I would say little more difficult. Maybe Albert knows a little more about that. No. It's possible on Windows, but on Mac it's really easy to install locally, to run it with Docker for Mac, and you can easily follow tutorials, and you'll learn a little more about how the modern way of infrastructure kind of weaves in together with the modern way of writing software. There's less of a line between sysadmins, developers, and it's kind of neat to experience. Is there any questions at all? Because I know for most of you it will be like kind of like an introduction in Kubernetes, and maybe I talked about some things that are quite advanced, some things that are less. If you have any questions, feel free to ask. If you don't, it's fine. All right. I hope you learned something. That's my goal. Did you? Raise hands if you learned something. All right, cool. That's good. Thanks.